Now this thing here, which I'm actually quite proud of, is my Lego shipping container. You know, even kind of works, you can open the doors. And basically these shipping containers are also known as ISO containers. Now an ISO container, ISO, is basically named in honour of the International Standards Organization. What that means is you can take this container, you can take it off a ship in China, you put it onto the ship, you know, and anywhere in the world, it gets to England perhaps, you take it off and it fits on one of the lorries in England, it would fit on a lorry in America or Pakistan or wherever it may be. So basically this fits a certain amount of criteria and it's a standard thing around the world. Now ISO, as in, you know, this comes up in chemistry quite a lot, but we also can use the word isotropic. And isotropic means that something is the same in every direction. So isotropic means that something looks the same in all directions. But there's another word that we can use, and this word, if I just cut this bit of cake here, which is quite a bit harder than I thought, is homogeneous. Now things which are homogeneous, if I just put that over there, things which are homogeneous have a kind of sort of uniform distribution of stuff. So this cake here has a fairly uniform distribution of bits of raisin. So I'm just going to write that down over here. So homogeneous just means that matter is distributed uniformly. What's that got to do with anything? You know, why have I built a Lego ISO container? Why have I kind of cut up some cake? Well, basically this is what we assume about our universe. If we think about all the stars and things, you know, there's not like a massive clump of stars at one part of the galaxy and nothing somewhere else. So if we think about the stars in the galaxy, they're kind of, and all, you know, all the galaxies in the universe, they are distributed uniformly, and whichever way you look, the universe appears to be the same, and that's the same for everybody else inside the universe. So if you think about perhaps if you were one of these raisins, whichever way you looked, there tend to be a sort of fairly even number of raisins in every direction, and if you were over here, you'd see the same in this direction, and this direction. So it doesn't matter where you are in the universe, whichever way you look, and wherever you are, wherever you appear to be, you see things which are the same. And, you know, this is the basis of the cosmological principle. And the cosmological principle just states that basically the universe is isotropic and homogeneous. And also the other thing is that the laws of physics are universal. So that means when we talk about things like Newton's laws of gravity, talking about the strong force, what makes up a proton or a neutron, it's the same everywhere in the universe, and therefore the laws apply equally everywhere. So, cosmological principle, the universe is isotropic and homogeneous, and the laws of physics apply everywhere within it. Thank you very much.